Hi, I'm Justin Garner with Engineered Air Balance, and today we're here in our training center in Houston, Texas, and I'm joined by Tony Gonzalez from Fieldpiece Instruments. And today we're going to shoot a video on electrical measurements on commercial HVAC equipment. We're going to be taking voltage and amperage measurements on systems that feature variable frequency drives. Let's get to it.
Fieldpiece has a full line of electrical clamp meters for the HVACR professional. From residential to commercial to refrigeration applications, Fieldpiece has the right tool to help you get the job done easier, faster, and better. In this training, we're going to focus on the wireless power clamp meters that have signal filtering and wireless capability to help you take more accurate voltage and amperage readings on commercial systems with variable frequency drives. So Justin and I are safely distanced in front of a 480 volt, 3-phase variable frequency drive pump system. And the question I have, Justin, is what is it about a variable frequency drive that makes taking voltage and amperage different than on a non-VFD system?
Well, Tony, that's a great question. And to be able to answer that question, we first need to talk about what does a power signal look like as it enters a VFD before it's processed. And here on our scope here, we have what's considered a pure sine wave, or what you would receive from the utility. And in this case, this is 60 hertz power, and you have each of 3 phases that are 120 degrees out of phase. And you can see here that they're perfectly shaped. Any meter that's rated for measuring 480 volts power could measure this type of signal. Next, what we'll need to do is change this and see the signal coming out of the VFD and show why it's different. So Tony, what we have here is a signal actually output from the VFD. And you can see it's quite a bit more noisy than that perfect sinusoidal wave that we saw entering. And the reason why is because this VFD converts that AC signal from the utility company over into a DC signal and then manipulates that signal to make it look like an AC sine wave. And it pulses and things to control torque and speed of the motor. And so what you have here, what the motor actually sees is an average of this signal here. But the problem is if we're using a meter that doesn't have filtering technology on it, it will pick up these pulses in this signal and actually measure the much larger amplitude than what the motor's seeing in that average. And so you could have an inaccurate reading.
Okay, so in the field, if a user is not using a meter similar to the Fieldpiece wireless clamp meters that have the filtering built in, what are some real world ramifications that a technician could come across?
Sure, good question. So if you see here in this signal, between the average and the peaks, you could have 10 or 20% or more deviation. And so if you have that much deviation in your voltage measurements and you're trying to do some very tight troubleshooting or analysis of your measurements either on the motor or the VFD side, that 10 or 20% accuracy could greatly affect the outcome of your troubleshooting.
Which could potentially lead to a misdiagnosis of the system.
Absolutely.
Well, great. Thanks for that, Justin. Now that we talked about the theory and we understand the differences, let's get our hands dirty and start taking some measurements. So Justin, so far you've done a great job of talking to us about the theory of the differences between a VFD signal versus a non-VFD signal. So let's put that theory into action and start taking some measurements.
Yeah, Tony. So the first thing that we need to talk about is safety if we're going to take electrical measurements. These are 3-phase power systems, so there's some other hazards we've got to be concerned with. Notably, we need to worry about arc flash. So you can see Tony and I have on our arc-rated clothing here. We're going to put on our shields over top of our safety glasses, and then we have our voltage-rated gloves. So let's get after it. All right. So the first thing we're going to do is use each one of these meters. We have a 680 here with the filtering and a 260 SC260 meter here, which is more geared for residential, light commercial. It does not have the filtering capability. Still a very capable meter. And we're going to measure the entering side of this VFD first. So I'm going to start with the 680 here. So we have 496 volts, 492 volts, 492 volts. So let me measure with the 260. Again, this is the utility side, so these should be very similar measurements. So we're in 494 volts, 490, 490 volts. So very similar voltage measurements between the two. So the next thing we're going to do is we're going to measure on the leaving side, and I'm going to start with the unfiltered measurement first. And we're going to see what we get on this with the unfiltered measurement on the leaving side. So we have 372 volts. 374 volts. And 374 volts. So it's important that we remember that number, because now I'm going to use the filtered meter, the SC680, and there's going to be a vast difference. So you can see here we're at 237 volts, which is much less. 237 volts. And 237 volts. So quite a bit of difference between those two. And we know that the filtered measurement is a lot closer to the VFD because we've got an output voltage here of approximately 240 volts. So this just proves that definitely in these applications we need that filtered measurement.
Okay, so why would a technician or contractor need to actually take this measurement with the meter rather than just going by what the panel says?
That's a great question, Tony. So when you're talking about a service perspective or an independent verification perspective, meaning testing and balancing or building commissioning, it's critical that we get the most accurate measurement. And so from either one, we could be troubleshooting this VFD, or we could be troubleshooting the motor downstream of this VFD, or from a verification perspective, testing and balancing or building commissioning, we want to make sure that we get a third-party measurement or a very, very accurate measurement to verify this equipment. And so that's why you'd want to use an external measurement versus the drive itself.
Perfect. That makes sense. So you've done a great job of covering the voltage here. So how does the current side play in all this?
No, that's a great question. So we focused on how the voltage is different, but there really isn't a difference on the current side. Either one of these meters, or any meter for that matter, that's accurate to measure this type of system, will measure the current the same way. Doesn't matter whether it's entering or leaving a VFD.
Interesting. Okay. Well, that's something new that we've learned today. Is that the filtering comes into play when you're measuring voltage on a VFD, but not so much when you're measuring the current side.
That's correct.
Awesome. Well, thanks for this great explanation, Justin, and on teaching us the importance of using a meter with filtering technology to get an accurate voltage reading on variable frequency drives.
Thank you, Tony. Thank you for joining us today in the Engineered Air Balance Training Center. And thank you, Tony from Fieldpiece, for joining us for this electrical training session.
Thanks for having us, Justin. We really enjoyed it.
Absolutely. If you'd like to see more of our training content, please visit our social media page. If you'd like more information on our training courses, please visit our website at eabcoinc.com.